working as a data engineer in Wipro. I have overall 3.11 years of experience, mainly in data engineering field. Transformation, it depends. Let's say we are using PySpark also for transformation, and we are using, in some cases, there is a custom SQL script for transformation required. So it depends on business to business, use case to use case.
So, but do you know like what are SCD and how to set a particular size of the broadcast in Spark?
So we have spark.config.set. So we have a property inside Spark. So we can set.
So, can you specify, tell me like what are the different ways by which you can specify the schema inside CSV?
So we can give one infer schema, okay, in which the user is not specifically giving a schema.
What are the difference in the Python list and Python array? We have first round of mock interview on the data engineering. So before starting, can you introduce yourself?
Sure. So my name is Priya Chauhan and I'm working as a data engineer in Wipro. I have overall 3.11 years of experience, mainly in data engineering field. And if I talk about my work experience, so I've started from Java Advanced training. After that, I allocated into a project that was a telecommunication domain and the client was from Africa. There I got a chance to work on PySpark and SQL. After that, I allocated into investment banking project that again from USA, wherein I worked on the data mapping projects. After that, I allocated in Chevron, that is again energy and utilities project, again from USA, wherein I got the chance to get certified Azure Data Engineer Associate level certification, and that too within a limited period of time. After that, I joined this automobile industry, and that is again from North America client, wherein my tech stack was majorly on. I got the chance to work on migration project, wherein my job was to migrate around 200 tables from on-prem Greenplum DB to Snowflake. So here we are using Snowflake as a central data repository using AWS services. So we use Scoop as an extraction tool, we use PySpark as a transformation tool, and to load the data, we use simple copy commands. Okay, that is one part. But I also got a chance to lead a team of manufacturing data engineers to help them implement data engineering pipelines using Azure services such as Azure Blob Storage and Azure Data Factory. And also the automation part in AWS. So we do it using Airflow, okay, to manage orchestrate our data pipeline. So yeah, that is about my tech stack and the work experience.
So in which project where you're using Snowflake, so are you transforming your data on Snowflake or you are using some AWS services before injecting it into the Snowflake data warehouse?
Transformation, it depends. Let's say we are using PySpark also for transformation, and we are using, in some cases, there is a custom SQL script for transformation required. So it depends on business to business, use case to use case. So we use both.
Okay. So like AWS also has its own data warehouse like Redshift. So why do you think we are choosing Snowflake other than Redshift, which is native to AWS?
Okay, there are a lot of use cases. Although I'm not have good exposure on Redshift, but as I've worked on Snowflake, I can explain the best part of it. The very first part is the faster query processing. Okay. The second part is its native SQL engine, which provide very good features and unique features than other traditional databases. Let's say we have one drop statement. Okay. In accidentally, if we have to drop the table in on-prem, we have to go to data admins, and that will take a lot of time to retrieve that, to restore that table, which in that period of time, there will be a lot of pipelines failures. Okay. But that in case of Snowflake, there is a one simple query which will take around millisecond to restore that table. That is one feature. Another feature is it's simple warehouses which help us to faster the process the query faster. That is third feature of Snowflake. And fourth is, I will say, the role-based access control, which help us, which make the lives of easier. Let's say for data engineering, we have a separate warehouses and we have a separate role. Similarly, for data science, data scientist workload, we have a separate warehouse created for them, and the roles also different. So these are the some of unique features that I have encountered with. Also, the fourth feature that I'll talk about is the indexes feature. So as in traditional databases, we create indexes, right? Just to store a pointer of each and every row. But in Snowflake, we don't have that concept. Why? Because we have multi-clustering enabled in Snowflake. Automatically, Snowflake stores the data in a compressed format, and that too is split according to the number of columns. So yeah, that is the fifth feature that I would like to consider.
So like in Snowflake, what do you think is clustering by closed does?
Clustering means, splitting the clustering means grouping, right? And clustering on the basis of what? On the basis of columns. Let's say we have one table, okay, in which we have ID and name. Now let's say IDs are increasing, okay, 2 to 5, or let's say 5 to 10. So in one micro partition, there will be, let's say, 1 to 5 row, and how it will be splitted? Column number 1 also, column number 2 also, column number 3 also, column number 4, depending on the rows. So in one micro partition, there will be rows ranging from 1 to 5, okay. In second micro partition, similarly, it will be proceeding on. So because of this format, the compression becomes easier, and also it is automatically managed by Snowflake and taken care by Snowflake. But again, if we want to use any other compression, we can define it inside the while creating the file format itself.
So like, are you using Snowpipe or a copy into statement while loading the data from S3 to your Snowflake warehouse?
Yes. So we are using normal copy commands because we are dealing with batch time data. It's nothing like we want to, capture whenever the file is arriving, we want to load it as it is. No. So it's batch time data. So we use simple copy commands.
And for those copy commands, are you running inside Snowflake or running inside Airflow DAG?
Running inside Airflow DAG, but it will consume the Snowflake warehouses only.
Okay. And what are the warehouses in Snowflake?
Warehouses, it's like the compute which is processing your query, and that is running inside the query processing layer. Okay, and it comes under t-shirt sizes. Let's say we have very small access size. We have a multi-cluster warehouse, especially when we're dealing with the corporate data lake. So in that case, we have multi-cluster data warehouse just to automatically scale up the number of compute cluster nodes required to run a particular query.
And what are the different tables in Snowflake?
So we have 3 types of table: transient, temporary table, and permanent table. So let's talk about temporary table first. So temporary table will be, let's say I want to test something, but I do not want to implement it. Okay, I want to have some POC, have some validation test, and then I want to later on implement it once I will show it to my boss or manager. In that case, I want, like, as soon as I leave the session, it should be dropped. So that is temporary table. Okay. Now what is transient table? I do not want to drop it. Let's say next day if I'm coming and my session becomes, out of time, then again I work on that table. Again I want to work on that table. In that case, I'll be creating the transient table. But now I'm very sure about creating that table. I've got all the approvals from the business user after understanding the use case. I want to create it definitely. So I'll be using permanent tables.
So currently you are using which tables in your data warehouse?
Permanent table. Because what we do basically, we will receive a request. We'll receive a request along with the metadata table. We'll have a sprint planning. Okay, if with huge number of tables, we'll understand the justification of table. After that only we'll go ahead and we will create that table. So it's nothing like we get a request and we simply create the table. No. So always we create permanent table.
So are you also implementing the data models inside Snowflake?
Data models, you mean to say like dimensional modeling or fact tables like that?
Yes.
So in one of the use case I implemented, I got a chance to work on dimensional modeling, wherein I had to build fact tables and dimensions tables.
So what are you implementing, the star schema, Snowflake schema, or Snowflake schema?
Snowflake schema.
Okay. So what do you think is the advantage of Snowflake schema over the star schema?
So star schema, basically, if I talk about normal example, let's say if we have a fact table, let's say it consists of some order ID or some book ID, okay. And with that, we have some a dimension table, let's say customer ID table, okay, in which customer name will be there, customer ID address will be there. And if I talk about realistic example, let's say if we have a sales table, and with respect to that, we have sales ID table, salesperson table. What we want to further, further aggregate that into, we want to granularize the details of the table. So we have to create the multiple dimensions with respect to one dimensional table. Maybe it will link to another dimension table. So in that way, that Snowflake schema will help us to further get the more insights of the data. Rather than getting one insight, we'll get multiple insight and to more level of granularity. So that is the advantage.
So have you also implemented SCDs in your data warehouse?
No.
So, but do you know like what are SCD and
No.
different types of? Okay.
Yeah, it's a new word for me, but I will make a research on it.
So just to it's slowly changing dimension. Maybe it's like okay.
Okay,
So
slowly changing dimension. I read about while preparing for Azure Data Engineer certification. So it's like whenever we have, let's say, for example, we have product IDs, okay, and let's say if later on some more product IDs came into picture, okay, with respect to the same product ID, we have a now different corresponding attributes to it. So in that way, we have to change it, or let's say we have to keep a historical records of it. So maybe that is what I know
yes,
as a part of slowly changing dimension.
yeah. So I am sharing you over email one simple question. So would you be able to share your screen?
Sure. Let me share my screen first. I'll be sharing my entire screen.
Okay.
Let me know once you're able to see. Have you sent the question?
Yes. Can you refresh?
Okay, I got it.
So let me explain the question. So this has been given a table, right? So we have like different columns: ID, date, and temperature. And you can consider the date as consecutive dates, like 1, 2, 3, 4, right? And these are the temperatures 10, 25, 30 on a particular day. So we have to find a SQL query to find all those date ID where the temperature at given row is higher than the previous day temperature. For example, if you see the second row temperature is 25, which is greater than 10, right? Similarly, temperature at ID 4 30 is greater than 20. So the output would be the ID 2 and 4. So this is the SQL. You need to write a SQL query for this question. Is the question clear to you?
Yes, it's clear to me. Okay.
Okay.
So in that case, if I need to compare with the previous date, then I need to use the lag function here, which will help me to get the previous row, and then I can easily compare over that.
So can you write a SQL query for this one?
Sure. Lag of temperature over
As
so this is my, let's say it's a temperature table. Select ID. So you in the output result you only want IDs, right? Or the date?
no, all the columns.
All the column. Date, temperature, where, temperature is greater than previous temperature. Yeah, so this will give me the respective result. 1 minute. This will give me the yes.
So like you are using lag over partition by date. So what does the intermediate table look like? Can you write an additional column lag in the existing data set?
So here it will be null. Here it will be 10. Okay, so here it will be 25.
Yeah.
Okay, I did not see this 25, and here it will be 20. Okay. So our resultant will be, so we will get this result in our output query and this result in our output query.
Like you're using partition by date here. So won't be there would be 4 different partition on the date column.
Okay, sorry. So in that case, I will use only order by, and that too by ID. That I missed.
Okay. And it's the same question. I say like you don't need to use window function. Is there any approach you think we can implement this question?
Okay, apart from window functions.
Yes.
Yeah. So I was saying that without window function, currently I cannot think of any other approach just to compare the values of the previous row.
Okay. So if I give you some hint, like if you can use some join functions, some join and some date difference, because one hint is date here is continuous, and if I say you can implement it through join, so can you think of something?
Okay, so if I use join here and if I do inner join on the same table, then I can, okay, so select ID, date, temperature from, let's say, temp table, inner join, temp table, let's say table 1, on temp table 1 dot ID is equal to temp table 1 dot ID, where temp, let's say I'm taking alias as P1 and here I'm taking P2. I will say where P1 dot temp is greater than P2 dot temp. Yeah, I'm not sure whether this will be giving the correct result or not.
This won't give, right? So
Yeah.
because we have to find the previous day, we have to compare every row with the previous day temperature. So
Right.
okay, no worries. We can move to the next question. In the meantime, if you can think on this, like try to work on your joint condition. In the meantime, I am handing you the question. Like
Sure.
the thing was, you need to compare a particular row with the previous day temperature, right? So you need to find some differences in the dates.
Right. Right. Okay, so I can think of one more of the. Yeah, this experience.
You can get this, yeah. So let's move to the Spark questions in the meanwhile.
So when we talk about the cluster mode, so it's like we are submitting our application with the in. Let's say we are doing a Spark submit command. Okay, that will be over the cluster. So it will be, we are giving the parameters, all the arguments, and all the things will be taken care by the cluster. Okay. But what happens in the client mode? We are running our job in an interactive mode. Let's say line environment. So that will be the difference between client and cluster mode.
Okay, so in production, what do you think? Which cluster mode or client mode we should use?
we'll be using the cluster mode only while working in production.
Okay. What is the difference in repartition and coinage in Spark?
So repartition is used to increase or decrease the number of partition, but coalesce will only be used to decrease the number of partition. So coalesce will be requiring the less shuffling of data, whereas in repartition, let's say if we want to decrease from 200 to 4, so it will be requiring shuffling of data. It will be more shuffling of data in comparison to 4. But when it comes to the results, we have to compare. Let's say if we are comparing from reducing from 200 to 5. So if we are doing repartition, it will be faster because it will possess that partitioning feature. But whereas in coalesce, it will not do that. So in order to repartition to coalesce to such a low number, that is, let's say coalesce to 5. So it will, the processing time will become larger, and in that case,
Okay, your video was freezed for some seconds. Yeah. Okay, so I was asking like, what is broadcast join in Spark?
so broadcast join is like, let's say if we have a history data, okay, and we have, let's say, incremental data coming, which is what, okay, every time, let's say only, let's say 100 to 200 records only are coming. So in that way, we can leverage broadcast join. So what it will do, the smaller join will be fit into the memory, okay, and that it will be distributed over all the partition, and with the larger data frame will be sitting in one node, okay. So in that case, we can say the smaller data frame is broadcasted to every node, so that it will act as a lookup table for the larger data frame. So that is broadcast join.
And how to set a particular size of the broadcast in Spark?
So we have spark.config.set. So we have a property inside Spark. So we can set auto broadcast threshold, and we can give the value according to the data, according to the value of that. If we have, let's say, 200 MB of smaller data frame, so we can give that value inside that our property. And if we want to disable it, we can set -1.
So my next question would be like, if you are doing a join and you are particularly broadcast hinting at a particular DF, like df1.join, and for second DF you are broadcasting hinting it, right? But that particular, say, auto broadcast join threshold is 10 MB, just taking an example, and say the table which you are trying to join is 20 MB. So will that results into broadcast join or some other join?
It will not result in the broadcast join. Rather than it will throw an out of memory error.
So you are saying that configuration will be the one which will be preferred here instead of the broadcasting.
Right. If it is not fitting into the memory, definitely it will raise an out of memory error.
No, here memory is not the concern. Here the question is more around the config and the broadcasting. Which one would be the preference here?
Okay, so we have to set the config property first. After that only we should go forward for the join, that broadcast join.
Okay. So I am shared you in the chat. So this is basically df.group by on some column, and you are doing count as an aggregation and doing another count. So are these two count the actions here, or are they both the transformations here?
Okay. So count will be a action here. Both the counts, it will be an action.
So you are saying group by department dot count. Here count is also an action.
Yes.
So okay. So another question is around the CSV file. So suppose you are reading your CSV file, right? So there are different ways to specify the schema. So can you specify, tell me like what are the different ways by which you can specify the schema inside CSV?
So we can give one infer schema, okay, in which the user is not specifically giving a schema. And the second is if we define the schema. So that will be more preferable, because in that case, Spark will not be have to perform more work, because we are explicitly providing the right data type by defining our schema according to our data structures.
Okay. So like in case I'm doing option infer schema equal to true, and I'm also doing header equal to true in my spark.read.csv data frame close. So how many stages do you think it will trigger?
I think it will trigger 2 stages.
And the reason for that is?
Reason for that is first of the thing is infer schema. It have to scan the data set, right? And the second for it, header is equal to true. So it has to get the first row also. So that is the reason.
Okay. So inside Spark, what are the different type of join other than broadcast?
So we have left join. Just like the 4 SQL joins, we have 4 SQL joins. Apart from these, we have left anti-join and left semi-join on.
So do you know what a sort merge join and shuffle has join in Spark?
Shuffle has join and sort merge join. Shuffle has join, I think it's one of the type of broadcast join.
Okay.
Yeah, but I'm not very sure on it.
Yeah. So like, can we do repartition on a specific column as well?
Repartition on a specific column. Okay, haven't tried yet. But I can think that if we are using the partition by clause and then if we are doing the repartition, then I think we can implement it.
Okay. Like, have you tried any join optimization in Spark when you have 2 different large tables in your data?
2 different large tables and then we have to join. Okay, so I've only used this left anti-join in that type of scenario. Other than that, I've not used join.
Okay. So what is the partition pruning in Spark?
Partition pruning, I can say one of the optimization technique in Spark. Let's say if we have a column, let's say some date column, okay? We have a month-wise data and I want to partition it using that column only, okay? So if we are giving partition by that date column, so what Spark will do, it will create just like a windows over that particular date column. Let's say for month 1, it will group into one partition that will sit on one node, okay, one executor, and another partition will be set on the another executor. So that will be called as partition pruning.
So extending on to this question, so say my data is partitioned on say date column, right? And while I'm reading the data set, I am specifying filter on some other column. So do you think will the partition pruning will happen here?
Okay, so you are using partition by along with the filter column.
No, so I'm saying right by writing the data, say I'm partitioning on say date column, right? But when I'm reading the data and specifying the filter condition, I am filtering it from some other column, say country or some other column. So do you think will the predicate push down and partition pruning will happen in this scenario?
I think it will happen because predicate push down, what it is doing, it is basically acting as a where clause. Okay, you're firstly limiting your data and then you are partitioning your entire data set.
Okay. So can you again share your screen?
Okay. Entire screen.
Yeah. To do a
Yes.
self join between 2 data frames, how can we do that in Spark, PySpark?
Sure. Let's say we have df1 and df2.
Yes.
So df3 will be df1 dot join df2. If df1 dot, let's say some column, let's say
ID.
df2 dot id. Okay, and you said self join, right?
Yeah, you can do inner join.
Yeah. So this is how the syntax will be. The data frame which you want to join, the condition on the column which you want to join, and the type of join.
And like in this particular join, both this table have the same column name. So when I'm trying to read df3, won't it result me into the duplication key error or something?
Okay, so in that case, I think we can use drop column in this scenario.
Right.
That, yeah.
Will you use drop or will you use just select here?
Okay, so what I have used is drop.
Yeah.
call of, let's say, the second that duplicate column, whatever we the name. So yeah, this is how what I will do.
So how you will reference the duplicate column here? To say duplicate column is a name. Just be taking an example again. Or you can say ID is again duplicate column, right?
So in that case, what I can do, let's say ID is one duplicate column, right? So what I can do, df.id dot alias ID dupe or anything, any column you can say. This is one way. Or the second approach, as you said, selecting the column, that also we can do. So firstly, we can select the column and that we can do. Let's say df2 is equal to select call of df2 dot select call of ID, and I will say take it as alias, another name, another ID, let's say, comma, call of your other column. Okay, some date column or something. So this is also one another way that you are talking by selecting also. After that, we can implement our join.
Okay. I'm not exactly sure if that would work. Okay.
Yeah, that will. In this case, if you are giving an alias, okay, in this case, so the column name will be different here, and then we can perform the join. So here,
The join thing is
yeah, go on.
So yeah, I have sent you another question on the email. If you can open that, yeah. So this is a problem where we have a list of lists with different columns like A, B, C, D, E, F, G, H, I, J, and we have to basically split it into different columns and then split the actual value of each element into different columns.
Okay. A, B, C, D, E, F, G, and or this. So there is one way that I can think of, that is the explode function. Yeah. So let me copy this. So df1 is equal to let's say this is my data. Okay. Tag dot read dot is
Consider it as df1 only. That is already there in the data frame.
okay.
Maybe some RDD or something.
Path dot create data frame. Data is equal to data and schema is equal to your column 0, column 1, column 2, column 3.
These are single columns currently when you are reading the data. So these are basically values of single column here, yeah. So you can ignore this df1. You can just consider this is already df1 here, and then you can write
df2 is equal to df1 dot.
You can ignore the syntax. I just want to know the approach as well. Like
Okay, so approach will be explode only. Explode will help us to split this into multiple rows. So A, B, C, D, and E, F, G, H, and I, J, J. So it will be splitted across multiple rows. So one of the array it will be splitted across multiple rows. So this is what I can think of the explode function in PySpark.
but then again, it would be a single column, right? And 3 different rows.
Okay. The other function that I can think of is
You can think of some split or maybe some looping here. That again would be an option.
so I can use for loop here, and I can make use of split function based on the comma delimiter, and then I can keep on adding values to my data frame. That is another approach that I can think of.
Okay, so you are saying you can use for loop here. So
Yeah.
how on which particular side you will iterate that for you?
On which particular side?
Like
So
some
the
elements have four values, some have three, some have five maybe.
so it will be considered into one row. Let's say if I'm reading it, it will be value. Inside it, it will be coming into one row. Okay. So I'll be splitting it based on the length of the row. Okay. Based on the length of the row. So my loop will be iterating into for I in length of list of the this list first element. Okay. Then second element and then third element. So in this way, the fourth element, let's say in this approach, we have this four element. So it will be added one by one, A, B, C, D. But in this case, it is having three elements. So it will go only 0, 1, and 2. So it will add E, F, G, and the last value it will read it as null. So that
You can also find the maximum size and then iterate over that maximum
Yes.
size instead of
that also we can
Yeah.
we can calculate the maximum size and then we can iterate over that. Yeah.
So you can stop sharing your screen again. Yeah. So coming to now Python, like so, what are the difference in the Python list and Python array?
Okay. So list and array, as much I aware, both are same only because these all are sequences. Whether it is list, array, whether it is string, dictionary, anything. These all are sequences in Python data structure. So these are same. And list is and array is also mutable, list is also mutable. So I'll consider is same only. It's just a naming convention what we taught in C programming language or Java and what we are reading it in Python. So it's same only. There is no difference.
So in the implementation wise, do you think it's same, right?
So I'm not aware of other programming language. So I've only worked on Python only.
So is Python list mutable or immutable?
Yes, it is mutable. We can change the element. We can add the element. So we can perform modification in the list.
And if Python list contains homogeneous data type or it can contain heterogeneous data type as well?
Heterogeneous data type. So we can have inside it, we can have tuple also, we can have sets also, we can have strings also. Any type of data type.
Okay. And can you explain me like what is dictionary in Python?
Yes. So dictionary are the kind of key value pair. With respect to key, we will have a value. So that is called a dictionaries in Python.
And what is the time complexity you think of searching for a particular key in a dictionary?
Searching for a particular key in dictionary. So it will be depending on the length of the dictionary. Okay. So that will be, I will say, VGO of n. The time complexity will be VGO of n.
Okay. What are the lambda functions in Python?
Lambda function, we say it anonymous function because it's not like we are defining it definitely using the def keyword. So it's like an anonymous function. One line in the one line only, we can implement it on any set of data set. Even it is in PySpark, we can implement it.
What are generators in Python?
Generators are like, let's say, if we want to generate a set of keys, okay. So I'm not worked on more on it generator, so I'll do research on it.
Yeah, no worry. So do you think what is tuple is immutable or mutable data structure?
Tuple is immutable.
So can we store tuple as a key inside dictionary?
I think we can store it.
Or similarly, can we store list as a key in dictionary?
Yeah, so dictionary is again comes as a mutable. So we can store any type of data structure inside dictionary.
So you think immutable, mutable both can be a key inside the dictionary key? Okay.
Inside the key you are saying?
Yes, yes.
I think yeah, we can store it.
Okay. So what are the deep copy and deep copy in Python? Shallow copy, deep copy.
Yeah, deep copy and shallow copy, yeah. So deep copy, so everything works as a references in Python. Okay. So when we talk about shallow copy, there is no another heap is created. But when we talk about shallow copy, a separate heap is created. for the object for which we are copying. Let's say if we are copying a list, so that is a part of shallow copy and deep copy, type of list copying. So yeah, if it is a deep copy, then another storage will be allocated to that. If it is a shallow copy, there will be no storage allocated.
Okay, so can you share your screen again and we can do one Python question and then maybe we can wrap up the session. Yeah. You can one more element you can put in the beginning 4. Yeah, 4, 1, 3. Yeah. So question is basically you need to find a duplicate element in this list and you can consider a situation that only one element will be repeated. So in this particular test case, in this particular example, you need to give me output as 4.
Okay, so the duplicate element in the list.
Yes.
Okay, so I'll be having a dictionary. Let's say it's frequency. And I'll be looping inside the list for I in range of len of yes. And what I will do, frequency, as it is a list, so I'll be keep on getting the element. Okay. Frequency dot get I, and I'll be adding 1 over it. So what get will do, it will get the if it is not present, it will get the value, else it will keep on adding 1. Okay. So let's say now I will say for value in frequency dot value, if value is greater than 1, print value. So using this approach, if it comes 4, firstly it will be 1 only. Okay, for 1 also 1, 3 also 1, 5, 6 and 2 also 1. But again 4, then it will add plus 1 to it and it will become 2. So whenever the value is greater than 1, it will print out that element, and in that case it will print 4.
Why are you creating nested loop here?
So first time I need to iterate through list, and second time I need to iterate to, okay, I can do one more thing here. Okay, so once my dictionary is created, I can have this approach also. Yeah, this will also give me the preferred result.
But why are you because remember the condition which I said, there will be only single duplicate element, right? So do you think we need an extra for loop here, and we can just simply while creating a dictionary we can get the output?
So you are saying that I do not need to use this for loop, right?
No, not below for loop.
The below for loop I do not need.
I'm just asking you, like, remember the condition, there would be only single element that is duplicated. So think on this direction. If you need a for loop, or if you can, while creating a dictionary, you can do the same.
Okay. So, okay, here also I can do one thing. So every time it will keep on adding elements, and without using for loop also, I can add this condition. Yeah, I think this will also work without using this for loop.
So you are saying value would be basically the value of a particular key, right?
Sorry. That's no worries.
So I get the idea. So what do you think would be the time complexity and storage complexity of this approach?
I think if I am having two loops here, so it will be VGO of n, iterating to every layer, every list element, and here it will be iterating to every list key, every dictionary key. So the time complexity will be 2n. So yeah, it will be VGO of n.
And the storage complexity, are you using storage complexity will be there or get like O1?
I think we are creating an extra space here, that is the dictionary. So it will be a VGO of n.
Okay. We go and okay. So any other approach you can think where we don't need any extra storage or we can do it in linear storage complexity?
Okay, I can do one more approach.
Mhm.
As you said, there will be only one element.
Mhm.
Let's say I'm creating a boolean. Boolean is equal to true. Okay. And I'll be for every I in one. If mm, if I is equal to, let's say,
Can you explain the approach? Yeah, maybe we can see.
I can think of one more stuff. While iterating the pointer over here, let's say
Mhm.
every time I is equal to 1, I is equal to 2. Okay. And every time I'll be comparing the element with that for every pointer. And if I get the same element again while comparing, I can make that bool is equal to false. And in that case, I'll not be needing to iterate the rest of the element of the list. So that is another approach that I can think of.
I don't get how you will keep track of the previous elements here.
Right. So in that case, I'll be needing another data structure again. So that will be not be the right approach.
No, have you studied about XOR operators in Python, bitwise operators?
Dot operators. No.
Okay. So yeah, that's also my side. Yeah. Thank you so much.